In this video, you're going to start the process of converting all three JavaScript applications over to the boilerplate project structure. So we'll be able to take advantage of things like Webpack, Babel, JavaScript modules, source maps, and all of the other awesome stuff we've set up. Now, actually getting this done is going to be pretty easy. Essentially, we're going to clone the boilerplate folder. We're then going to take some of the files from the old project, copy them over to the new one, and make a few changes to take advantage of things like the JavaScript module system and the slightly altered directory structure. For the most part, though, it's really not going to be that bad. Now, we're going to go through this conversion process for the Hangman application together in this video. Then we're going to go through the conversion process together for the Notes application. And finally, as a challenge, you'll be converting the To-Do app over to this new project structure. But let's kick things off with the Hangman app. Now, before we clone the boilerplate folder, I do want to make a few changes to it. First of all, there's no need to keep node modules around. When I clone the boilerplate, I can always run npm install to generate node modules from scratch. The second thing has to do with the source directory. In the source directory, we have our three files. Now, index.js is a very important file since this is the entry point for Webpack. This file is going to stay around. The only thing is that the other files don't really make much sense anymore. Those were very useful when it came to exploring how JavaScript modules work, but this code isn't going to end up being part of the boilerplate. It doesn't make sense to start new projects off with these weird examples. So I am going to completely empty index.js, then I am going to delete scream.js, and we are going to delete utilities.js, and there we go. Now we have a nice, clean boilerplate project folder that we can actually work with when it comes to building out our other applications. So from here, we're going to start the process of converting Hangman over to this new system. The first thing I'd like to do before cloning boilerplate is to rename the Hangman directory. I'm going to call this Hangman old since we're about to create a new folder, which I'd like to call Hangman. Now let's go ahead and actually clone boilerplate. I'm going to right click, reveal in Finder or your File Explorer, depending on your operating system. And the goal here is to just create a copy of the boilerplate folder. I'm going to duplicate that folder. Then we want to rename the folder. I'm going to call this one Hangman. So now we have two directories. We have Hangman, which is just a copy of the boilerplate, and we have Hangman old, which contains the old application for the app before we knew about Babel, Webpack, and JavaScript modules. Now we can actually get started with the process of converting from Hangman old to Hangman, and it's really not going to be that bad. Let's start with the easy stuff. We're going to take the images directory and we're going to drag that directly into public for the new boilerplate project. There is no need to make any changes to that. I'm also going to take the styles directory from Hangman old and drag that right into the public folder for the Hangman application. Last up is index.html. I have the new version right here and the old version right here. Now, there's a lot of important stuff in this old version we want, so we have a couple of ways we can solve this problem. The one I'm going to choose is to just take everything from the old version, copy it, and paste it over here. The only thing we really need to worry about preserving is the one script tag that loads bundle.js, and we'll take care of that in just a second. So I'm going to paste the contents in. We're going to delete all script tags but one, and we're going to change this script tag to load /scripts/bundle.js. So now the new index.html file, which has the Hangman specific stuff, is going to be loading the bundle file, which is exactly what we want. Now we can actually close down both of those HTML files. And the last thing to address are the scripts for Hangman old. We have app.js, which was our entry point. Then we had hangman.js, where we created the Hangman class, and we had requests.js, where we had some code for making those requests. What we're going to do is start with app.js. App.js was originally the entry point for the application. This is what really bootstrapped everything. Without this file, nothing would happen. That's the equivalent of index.js in the new project structure. This is the first file that runs. This is the starting point. So in the end of the day, a lot of the code currently in app.js is going to find its way in index.js. But obviously, we'll be taking advantage of the module system, so some changes will definitely be made. To start though, it's perfectly fine to take everything from app.js, everything but the comments of course, and copy those over to index.js as a starting point. Now that really just leaves two things from Hangman old that we haven't addressed, the Hangman file and the requests file. Both of these are going to get copied over to the source directory as is. Eventually, we're going to change these files to actually export things that index.js can import. I'm excited to get to that. So now Hangman old contains nothing we don't have in Hangman. We can actually go ahead and delete this folder as it is no longer necessary. Now that doesn't mean our current app is actually going to work. It's not, and let's talk about why. The biggest thing is that index.js is relying on things from those other two files that don't currently exist. For example, we are using things like getPuzzle. GetPuzzle isn't defined in this file, and we don't have access to it because with Webpack, each file has its own private scope. The same thing is true for the Hangman class used on the very next line. So what we need to do is set up these two files with exports and set up this file with some imports. That's going to bring everything back to its nice working state. Let's go ahead and start with hangman.js. In here, we have a single class we create, so there's only a single thing to export. I mentioned a few videos ago when talking about JavaScript modules that when a file just needs to export one big thing, I usually like to use the default export. So down below, we could get that done. Export, inside of curly braces, Hangman as default. Perfect. So now we are exporting the Hangman class from this file, which means we can import it from index.js so we can actually use it down here on line 24. I'm going to add that import statement up top, right here, import. Now remember, what we're grabbing is a default export as opposed to a named export. So I don't want to put stuff in curly braces. That's how we get named exports. For the default, we just put it right here. So I can call this one Hangman, though remember I could call it whatever I like. Then I'm going to say from inside of quotes // this is the source directory. In there, I want the hangman.js file. And remember, we are able to leave off the file extension. So now some of the code in here is going to work, but there are still problems because there's stuff in the requests file that I need access to. We have quite a few different functions that we take advantage of over inside of index.js. Now we actually do not use all of these functions. Some of these were set up as ways to explore how we can use asynchronous code. The only one we're actually taking advantage of inside of the project is getPuzzle. Well, we could choose to export the others. I'm not going to. You could even choose to delete them at this point since they're not being used in the actual Hangman game. Up above, I'm going to export this one. I'm going to export this as the default since it's the only thing I'm going to be exporting. Export right here. What was that called again? GetPuzzle. GetPuzzle as default. Whoops. Let's go ahead and see if I can spell that right the fourth time. Excellent. So we have getPuzzle being exported as the default export. We can save this file and go over to index.js and import. Import getPuzzle from inside of quotes // that file is called requests.js. Perfect. Now we have a completely converted application that should run as expected, and we can go ahead and test things out. I'm going to switch over to the terminal. Currently, both terminal tabs are in the boilerplate directory. I only need one terminal, so I'm going to close one of the tabs down, then use cd // to navigate into the correct directory. From here, we have to do two things. First, I do have to run npm install to install all of the modules listed in package.json. Once this is complete, we'll be able to run the dev server and actually test out our app. We're also going to deploy the production version live to the web so we can make sure that side of things is working as well. All right, it looks like we're almost done. Things are now up and running. Let's go ahead and use npm run dev-server to actually start up the development server. Once it's up, we should be able to refresh things in the background and actually see the Hangman game. Now, clearly the application is not working as expected, and that's why I wanted to go through this process together before setting you off on a challenge. Down below, we have a reference error. Regenerator runtime is not defined, and this is coming from line 1 of requests.js. That is where we define the getPuzzle async function. So the actual function regenerator runtime is never something we've referenced in our code. This is actually something that gets referenced after Babel processes our async functions. By default, it's not going to exist, which is why the code is currently failing. The good news is that with a simple tweak to our configuration, we can actually add support for this and get things working as expected. So we can use our async await functionality in all browsers. To kick things off, over inside of our other tab, I want to head back over to babeljs.io. The thing that we're going to be using under the docs dropdown is Babel polyfill. Now let's talk about what exactly a polyfill is. To do that, I'm going to go over to the try it out page. If you remember the try it out page from earlier in the course, we were able to see how our code got converted. On the left-hand side, I could create a class like this one. On the right-hand side, it would be converted to a syntax that the browser understands. Older browsers do not understand this syntax of using the reserved class keyword, so it has to get converted into something completely different which browsers do understand, like a function. Now this is a bit different from another thing that older browsers don't support. So we have our arrays, right? And we have array methods that we've used like for each. For each allows us to loop over each item. I provide to it the callback function like this. Now what happens in Babel? Well, Babel just transforms the arrow function to a regular function. It still leaves for each in place. And this is fine, because for each is a very standardized array method that's been around for a long time, so any browser that your app's going to run in is likely going to have support for it. There are a whole slew of newer array methods, though, that don't necessarily run in older browsers. One of the newer ones, which we explored earlier, was includes. So includes is just a regular old method. There's nothing new or fancy about it. It's not trying to introduce an entire new syntax, so Babel doesn't convert it. The problem is that older browsers don't necessarily support it. The polyfill fixes that. The polyfill runs before your code runs, and it adds support for things like includes in older browsers. So the polyfill runs some code to check if the array prototype has the includes method on it. If it does, it leaves it alone, knowing it's a modern browser. If it doesn't, it actually defines an implementation for us. So long story short, what we need to do is include the polyfill so we get access to the function Babel needs, regenerator runtime. Now all we have to do is install this, make a one-line change to Webpack config, and we'll be all done with this conversion process. I'm going to switch over to the terminal, shut down the dev server, and use npm install to install Babel-polyfill at the latest version, that is 6.26.0. Let's go ahead and run this command. That's going to go through the installation process. Now, the key to using the polyfill is to load it before we load our application code. That's going to require a simple one-line change to Webpack config. Right here, on line 4, we specify entry, and we set its value to a string. We can actually also set its value to an array of strings to load multiple files. So right here, what are we going to do? We're going to set up an array, and then we're going to set up 2 strings. The first one is going to load Babel polyfill. We'll give it a value in a second. The second array item is just going to be the old one we already had, where we load index.js. Right here, all we have to do is specify Babel-polyfill. Now the polyfill is going to load before our application loads. It's going to make that function available to us, and we'll be able to use async await. Over in the terminal, I'm going to go ahead and rerun the development server. That's going to go through the process of booting up the application once again, and once it is up and running, I'll refresh things in the browser. And this time around, we can see we did successfully get the puzzle. So our async function worked, and we should be able to actually go through the process of making those guesses with the data received from those HTTP requests. Now that our local development environment is looking good, let's go ahead and actually create a production build and deploy to production and test that out as well. If you remember, we had used those two services when hosting our websites. We had used Netlify as an easy browser-based way to host a website, and we had used Surge as a great command line tool for deploying applications. I believe for the Hangman game, we did use Netlify, so let's go ahead and knock that out. First up, over in the terminal, I'm going to shut down the dev server and use npm run build. Remember, we have to run this script to generate the production build. This spits out actual files to the public scripts folder. Now that we have the files there, let's go ahead and move over to the browser. I'm going to pull up netlify.com for the Hangman game. Take a quick moment to sign in. We have to select our application, Mead Hangman for me. Then we can head over to the Deploys tab, and down below, we can drag the public folder right here. I'm going to open up the Finder. From the desktop, I have to go into JS Bootcamp, Hangman, and it is the public folder we want to drag over. So I'm going to drag that over. That's going to create a brand new deployment, and we should be able to test it out by just visiting our site URL. And right here, I can see things are working as expected, which is a great sign. Now I should be able to still make those guesses. I can see the async function is working great. Everything is really smooth. So there we have it. This is the process for converting our old applications to the new system where we get the advantages of Webpack and Babel. It really wasn't a bad process. This time took a little bit longer because we were moving through it for the first time. The other two times will be nice and quick. Now there is one last thing I want to adjust before I wrap up this video. If I close all of the files and crack open package.json for the Hangman game, we can see we have our dependency Babel polyfill inside of there. I'm going to take this line, copy it to the clipboard, and then I'm going to crack open package.json inside of the boilerplate project folder. Right here, after Babel loader, I'm just going to paste that line in. So now we have Babel polyfill as a dependency for the boilerplate project as well. So we don't have to fix that regenerator runtime issue every time we want to use async or await. Now inside of Webpack, we have to make that small change to entry as well. So I'll remove this string, cutting it out to the clipboard. I'll replace it with an array where that string is the second item in the array. And the first item is just going to be Babel-polyfill. Perfect. So now the boilerplate project has the changes we made to the Hangman game. And when we actually clone this to work on the Notes app or the To-Do app, it's going to function as expected without needing us to manually go through that process again. All right, that's it for this video. We have a local dev environment for Hangman and a production environment all set up. I'll see you in the next one.